Wind power is the second largest renewable non-greenhouse gas producing energy source, surpassed only by hydroelectricity. Denmark produces over 20% of its electricity from wind turbines. In California, the wind installation at Altamont Pass near San Francisco has more than 5,000 wind turbines, and those at Tehachapi and Palm Springs have over 3,000 each. These California sites have a large range of turbines, from small units that generate as little as 100 kilowatts to some with 90-meter blades that generate 1.5 megawatts. Many countries are rapidly adding capacity, and within a few decades, wind power should provide at least 4% of global electricity. As much as 72,000 gigawatts of wind power might be commercially feasible worldwide, many times the current total energy demand. Winds derive from temperature differences between the tropics and the poles, between land and sea, and between Earth's surface and upper atmosphere. Electric power generated from wind is proportional to its speed, to the third power. Winds near ground level encounter many impediments, and their velocities approach zero. Velocities increase markedly with height above ground, but decrease with surface roughness. Because the power that can be extracted from wind increases with wind velocity to the third power, the hub heights of large turbines are usually placed 40 to 80 meters above ground. Evaluations of potential sites for wind turbines are based on average wind speeds at 50 meters above ground. Most of these sites are located just offshore, where land-sea temperature differentials drives winds and where open water presents few impediments. Modern wind turbines benefit from A. Improved materials such as carbon composites and aluminum alloys that reduce weight and increase durability. B. More sophisticated designs in which the angles of blades change with wind velocity. C. Gearboxes that translate slow turbine speeds into fast-spinning generator shafts. And D. Dynamic loading and braking that keeps the turbines from spinning too fast in high winds. Noise from a wind turbine increases with the fifth power of the speed of the blade tips, and so gearing and braking keeps the turbines from becoming a greater nuisance. The intermittent nature of wind makes it an unpredictable energy source. Worse yet, demand for electricity may not coincide with periods of high winds. For instance, Texas is the state in the United States that generates the most wind power. The hottest days in Texas, which have the peak demands for electricity to power air conditioning, tend to be those with the least wind. As such, the success of wind power depends on integration into a large energy grid with high capacities for energy storage, such as hydroelectric power. Danish wind farms, for example, export almost half of their electricity to neighboring countries such as Sweden and Norway that have large hydroelectric power storage. On the positive side, the cost of wind power has diminished to where it is competitive with other energy sources. Wind power, like hydroelectric, has negligible fuel costs and relatively low maintenance costs. Most of the costs are for construction and transmission. Ecological concerns about wind turbines center largely on injuries to animals that fly into turbine blades. Collisions with existing wind turbines kill 20,000 to 37,000 birds a year. By comparison, annual bird fatalities from collisions with buildings are between 97 and 976 million, with high-tension lines between 130 and 1,000 million, with communication towers between 4 and 50 million, and with vehicles somewhere around 80 million. Therefore, wind turbines are responsible for a minute fraction, less than 0.0003% of bird deaths from collisions with human structures. Wind farms also face opposition if their turbines obstruct scenic views. To improve their aesthetics, new installations have more widely spaced turbines which look less cluttered than old installations, and offshore installations are located further out to sea. For example, a 420 megawatt wind farm proposed for Nantucket Sound would place 130 turbines, each 75 meters tall, 8 to 15 kilometers from the beaches of Cape Cod, Nantucket, and Martha's Vineyard. Nonetheless, the turbines would still appear prominent on the horizon, and this project has been embroiled in controversy since 2001. In summary, number 1, fears of major accidents have stalled the use of nuclear electric power. Number 2, most of the best locations for hydroelectric power are already in use. Number 3, wind power is expanding despite difficulties in site selection.